All right, this video is for the Radian measure notes. This is lesson 6.1. All right, so radian measure is another way that we can measure angles. So radian measure can be described as theta. Looks like a 0 with a line through it. And theta equals L over R. Okay, so theta is the radian measure, so that's what we're looking for, of the central angle. Okay, L is the length of the arc intercepted by the central angle, and then R is the length of the radius. So if we have two of these pieces, we can find the other one. So if we look at this first one, a circle with a radius of 12 centimeters has a central angle of 270 degrees. Determine the length of the intercepted arc in terms of pi and to the nearest hundredth. So before we do anything, we need to convert the 270 to radians. Okay, make sure to convert radians to degrees. So to do that, if it's in degrees, we multiply it by pi over 180. Okay, if you want to do this in the calculator, when you do this in the calculator, if you type that whole thing in, if you do 270 times, let's see, pi over 180, it's going to give you a decimal, and we don't want that. What you can do is use just the numbers. The 270 goes on top, the 180 goes on bottom. Okay, and how we write this down would be 3 over 2, but we can't forget about that pi sign. Okay, so the pi always goes on top as well. So just be really careful when you're converting that way, because if you do the whole thing in the calculator, you will get a decimal. Okay, so we know that the measure of the central angle equals L over R. So we know the measure of the central angle. We're looking for L. And then the radius is 12. So how do we work this out? What we can do is we can cross multiply and divide. So we're going to cross multiply this way and then divide this way. Again, leaving the pi out of it. So we would do 12 times 3 divided by 2. 12 times 3 divided by 2. And we get an 18. But we can't forget about the pi. What you do is you just attach the pi to the end. Okay, so 12 times 3 divided by 2, if you want to do it in your calculator, if you want to do it that way. And so we can also, if it wants a decimal of that, we can type 18 pi in, and we get about 56.55 centimeters. Because we can't measure in pi. If we want to know the actual distance, sometimes we need a decimal. And so that's the length of our arc. That would be this piece right here. If I had an angle in the circle, that arc length, how far around the circle is it, is what it's asking for. So in this picture down here, we're finding the length of the radius. So again, first thing we need to do is we need to convert this to radians. So we're going to do 45 times pi over 180. Again, we want to do just 45 over 180 and get this fraction. What we get is we get 1 over 4. Don't forget about the pi. Pi goes on top. Now we can make that 1 invisible, so just pi over 4. All right, so central angle equals length over radius. So we know what the central angle is. It's pi over 4. The L, the length of the arc, is 16 pi. And then we're looking for the radius. So we can cross multiply and divide again, but something strange is going to happen here. So if we cross multiply and then divide, if you notice, we've got pi's in two places. Okay? The easier thing to do here would be the butterfly method. So this is the other way that you can solve these. Okay? So 16 pi times 4. I can just do 16 times 4. 16 times 4. And I get 64. So this would be 64. Don't forget about the pi. Pi times r is just pi r. From here, if we're trying to get r by itself, that's what we're trying to find, is the length of the radius. Same equation rules. Do the opposite. R is being multiplied by pi. So to get rid of that, we divide both sides by pi. If it cancels out here, pi on the top of the fraction, pi on the bottom of the fraction, it's going to cancel out there. And what we're left with is just 64 equals r. Okay, so for the calculator you can do some things, but there are some basic equation rules that you're going to need to be able to do these. So that's it for this video.